All right. So if neither of us have been you've never been to Indonesia, correct?
No, I've not.
All right. So
No.
neither have I. If we were going to plan a trip, where would you recommend we go?
To Indonesia?
Yeah.
Well,
Or Taiwan. We could, or both.
Taiwan?
What if we
Yes.
what if we do a whole? All right. Let's say I wanted to do Japan, Taiwan, and Indonesia in
that
the
would
same
be
trip.
terrific. Yes, I love Japan. Yes.
How many weeks would I need, give or take?
2 weeks.
Probably 2 weeks.
Ambitious one, 2 weeks.
Okay.
More relaxing, 3 weeks.
Okay.
So
Spend
just
most-
round it off to,
With my
just
PTO
round
break.
it. Yeah. Just round it off to a month.
Right.
And just
I mean, that
pick
would be
one
pretty
month
sweet.
and just be gone.
Where should we go? What's the best time of year? And what is the 1 to 3 things that we would have to certainly do?
Depend on the personality.
Sure. Okay.
So I don't really, your preference, right? But
Right.
I think in my preference, I don't really like if too crowded. So I will avoid avoid Christmas.
Okay.
Okay.
And then maybe April, March,
Yeah.
April,
Right.
and start spring maybe, but try to find not like the peak time for tourists. So
Right.
start with Japan because it's the closest, right? You go
Yep.
to Japan first, transit.
So I already like where this is headed because early
Yes.
spring, at least in Japan, we could potentially spring ski.
There we go.
But then also hit
Yep.
the cherry blossoms.
Cherry
blossoming,
blossom,
right?
yes,
Yep.
yes.
Then make our way to
yes.
Taiwan.
Yep.
Yes.
And then finish in Indonesia.
Indonesia.
Yeah.
Yes. And it won't be so hot in Indonesia.
Right.
Remember, we are
Yeah.
tropical. So
Correct.
if you go this time, then
It's going to be
No,
super hot.
yeah.
Yeah. it's
Crowds
super
might be
humid.
less though.
that's no in Bali. No,
No,
they never less. They don't have downtime. Yeah.
Oh, that's true.
Always busy.
like
yeah.
always crowded.
And we have to be open for spiciness, right?
No, not really.
Not really? Okay.
If you go to Bali, because I think it's very westernized, because a
Oh,
lot of
okay.
foreigner, so it's a lot of restaurant is foreigner friendly. They will accommodate your palate.
Sure.
They know how to
Tone it
adjust,
down.
tone it down,
Yeah.
Western spicy level.
Right.
Yes.
But so if we were going to go to Indonesia, where do you recommend we go and what should we do?
I wouldn't recommend Bali actually.
Okay.
Because
Yeah.
that's like the stereotypical, So you probably want to go to Labuan Bajo.
Okay.
That's new. So they have like a kind of cruise, but not really cruise. They call it penisi. So it's like a little ship, like a little boat, and then you can just stay there, and then you will go around the coast like that one.
Okay.
And then they have like a snorkeling, and it's very clear.
So you're kind of hopping amongst islands?
Yeah, like
Okay.
a little one. It's just
Yeah.
like 3 days, 3 nights.
That's cool.
Yes,
Yeah.
and it only like fit maybe like 8 to 10 people, so it's just
Okay.
your family.
Right, yeah.
So
Oh,
it's
that's
not
cool.
like
Yeah.
cruise the mass transportation.
Right, yeah.
No, but it's like personalized
Right.
experience.
That would be cool.
Cool.
Yeah. So,
All right. Let's so just start checking our calendars for.
Right. Next
but
spring.
definitely
Yeah.
to Taiwan.
Yeah.
Yeah.
Okay, I'm so biased because I love both. I was born in Indonesia, but I think I love Taiwan the
Taiwan.
most. You
Yeah.
know, the ambience, the structure, the
Yeah.
system, and
Yeah.
you will feel the safest there.
Okay.
Okay.
Japan is also equally safe. Like
Yeah.
you will give that sense that you can go out at 2 a.m. in the morning, and you can left. We left one time. My dad left camera, like a high definition camera in Taiwan, and 3 days later, it was outside, and somebody just pick it up and put
Oh,
it
really?
in there. Yeah,
That's
you
cool.
can
That's
you can
nice.
put your iPhone
Yeah,
like
it
that.
just- I just walk away from
Nobody
it.
will.
Here, not so much.
Yeah.
Yes.
My brother's been to. He went to Japan once, and then the next year he went back because he liked it so much.
Yeah, Japan like
So,
that. But it's
yeah,
just,
but I'd
Japan
be
is
curious.
For me. It's like a bit rush, Like
Yeah, yeah.
Yes, Taiwan is more chill, like laid
Okay.
back.
Yeah.
I don't know if it's Taiwan this year he's going to, or if he's going to
I'm like,
the
propaganda.
Philippines. So
Oh,
yeah, so his wife's Filipino. Filipino.
Yeah.
Oh, I
yeah.
see.
Yeah.
So we'll get into this. I know what brought you to Taiwan, but what was it about Taiwan that you really liked?
First, it's like maybe it's the sense of security first, and it's very foreigner friendly. I feel like Japan is not very foreigner friendly.
Oh, really? Okay.
So even though both Taiwan, like most of them speak Mandarin, but all the road
Street
and the
signs and
street
things.
sign, and then the public transportation, everything is like they have English in it.
Oh, really?
So
Okay.
it's like I cannot read. I probably can survive using Mandarin just to survive, like basic conversational, but reading and writing, it was too hard for me.
Yeah.
I don't have the capacity to, my brain. So, but the English help a lot, and then the people and Japan is very disciplined, as you can see, very disciplined country. So everybody was like in a rush, even though very nice, very friendly too. But Taiwan, because more warm, they're more laid back, so they're like very warm, and then feel like as a foreigner it was really nice. And I was a student at that time, and then good food. Maybe the food is more like similar taste, the flavor with Indonesian food, like more flavor, and Japan is a little bit lighter side.
Right.
So Taiwan is like in the middle. Indonesian food is heavy, and Japan is super light, and Taiwan is like in the spectrum between the spectrum. So right there, and then and it's clean, very clean, and very orderly. Like you have to, but not as strict as Japan. Like for example, in Taiwan there is a recycling. We have to recycle in Taiwan because it's a very small country, so they do not have land to landfill. They do not have that, so you have to recycle everything, the trash, plastic, paper, something like that. But it's easy that like when you walk on the street or in the MRT, there are always designated for trash, something like that, like the recycled trash. But in Japan, you cannot even throw trash on the road. You have to carry with you, come back to the hotel, especially Tokyo. I have to warn you that.
Okay.
So it's like, it's like the extreme spectrum. Indonesia, do whatever. No. You probably shouldn't, but the police will not give you fine. Or like in Singapore, for example, that I almost get fined. Like you cannot chew.
Well, right, I heard about that.
Yeah. Singapore, like every time I have to see the sign first because it's $500. And I was student at that time, like when I hover on, like so. Yeah, it's even now I don't want to pay $500.
Well, right. No, thank you.
So Taiwan is like lukewarm, like in between extreme spectrum, like Singapore or Japan. They're super clean, they enforce this rule, like very strict.
Right.
Yeah.
Okay.
I think you will love it.
All right. Well, the more you know.
It. Yeah. Well, before we book our flights, we'll get with you to get out.
Yes.
Actually, we might just take you. We're a translator.
Yeah.
You can be our designated translator
to meet my friends.
Yeah, perfect. Exactly. You have the ground knowledge. That's always.
Yep.
I'd love to.
All right. We'll collaborate on that, and we'll talk. We'll figure out some sort of like R&D studies.
Yeah.
Something.
Yeah.
I don't know.
Yeah.
Is this thing on? Welcome back to another episode of the Summits Podcast. Thank you all for joining us from wherever you get your podcast, or if you're joining us on the Heroes Foundation YouTube channel. Thank you for doing so. If you're on the YouTube channel and you haven't hit that subscribe button or the notification bell icon, please go ahead and click on those. Won't cost you a red cent. It won't matter whether you're in Indonesia or Taiwan or Japan or right here in Indiana. We'd love to have you. Thank you for joining us. All right, today we've got some international flavor. Dr. Damayanti. Doctor, welcome to the Summits Podcast.
Thank you. Please call me Nuri.
You're welcome. Why don't you give a little bit of background on yourself and educate us on your background, what led you into doing what you do, and go from there.
Okay, so I was born in Indonesia, and then I had my bachelor study in Indonesia in chemical engineering, and then my master chemical engineering and bioengineering. So I had a little background of bioengineering. What
made you decide to go into that? Like, what was your initial thought? I want to go into chemical and bioengineering.
Oh, it was a scholarship, a full scholarship.
Okay.
And Indonesia is a developing country, so like chemical engineering, and we are like one of the biggest production of natural gas.
Okay.
So chemical engineering is like they have a full scholarship, and then like a good in the foreseeable future, you have like a good outlook for job because there are a lot of
Sure.
oil and gas, and at
Right.
that time in my mind, oil and gas is it was needed.
Sure.
And then so I went to chemical engineering.
Okay.
And then after that, there was another offer, a scholarship. After in the end of my 4th year, I guess there were offer scholarship from Taiwan government, and then also chemical engineering. But so I took it because it's a full ride scholarship, and then I got to go to different country,
Yeah.
and then so. Yeah,
A lot
so
of
it was
benefits there.
it was
That's good.
financial. So I guess it was financial motivation in the beginning.
Yeah.
So okay, I just wanna experience the world, and then I always wanna travel.
Yep.
And then so okay, I went to Taiwan, and I don't know if here, but at that time in my country, like a TV series or drama series, it was very famous from Taiwan.
Right.
Yeah, so I was like, oh, I want to go there. Yeah. And then they give me a scholarship, yeah.
Nice.
And then
So how long is that about? Was that a 2-year program?
2 years, but I finished
Okay.
in 1.5 years.
Oh.
Okay.
So but a little bit different. Like I jumped major. So during my bachelor, my concentration was because it was oil and gas oriented. So it was like more like bioprocess, bioengineering.
Okay.
That you design the reactor or something like that. And then when I went to Taiwan, the scholarship at that time, we have to find a lab, like open position for the lab, and then because I was kind of late arrive in Taiwan, there was no longer open position, and then
Oh, okay.
the last lab that's still open, it was a quantum chemistry lab. So I have to jump into quantum chemistry lab, like it was kind of physics, chemical engineering department.
Yeah.
So I was like,
that's not my area.
it, yeah.
The first thing crosses my mind is how do you just fall into quantum chemistry? Like to me, that seems.
I
like
had
it's
no choice.
probably- Right.
I want to keep the scholarship and I want to keep going.
Yeah.
And then, okay,
Keep-
let's
yeah.
learn about this. Yeah.
Yeah.
But then, thanks God, I survived. but that was actually, that landed me a job. Because after that master, before I graduated, I got a job. And the job is because of my thesis. Because
Okay.
the quantum chemistry is like I was doing a simulation, computational study to study the we're Taiwan trying to develop fuel from water.
Oh,
We call
okay.
it a water gas shift reaction. So we have to find the right catalyst that will catalyze this process to convert water into fuel. And then the main thesis is to study, to compare what is the right catalytic plane, like from the aluminum at that time, aluminum oxide, like to measure the energy using a computational and then some quantum chemistry, something like that. Like we study about this aluminum oxide. But then upon graduation, there was a company in research, actually it's a government research center.
Sure.
They needed a researcher that knows something about aluminum oxide.
Okay.
That was coming
So is that
to
in
place.
Taiwan then?
In Taiwan,
Oh,
yes.
okay.
So then
Yeah.
I signed before I graduated, so I just worked in Taiwan for a couple years. And then my friend also got a job in different place, but we all best friends, like, we just together from the master, and then
Yep.
and then I don't know, for some reason, at that time maybe my cancer area, because I was diagnosed by cancer. It's the otolaryngal cancer, the laryngeal cancer on my nose, because the company. Oh yeah, this is the nice thing about Taiwan. The company always give us twice a general checkup. So every employee, full general checkup
Nice.
every 6 months.
Oh, wow.
We are
Yeah.
mandated to do that, and
Yeah.
especially even if our research is not a wet lab, our research was like computer. We still have. It's one of the wellness of the employee wellness.
That's nice.
So they catch that during like one of the, after my 4th year there or something, they catch that like a marker of the, just like a early marker of the laryngeal cancer. So they have to do biopsy on my nose. And because of my family history, like there are a lot of relatives that had cancer, like so many different cancer. So I was like, oh, maybe I'm in a time bomb right now. Like the sticky, like it's coming into me. But so I was, prior to that, I never thought about what I want to do, I just like a bumblebee. I just okay, there's no scholarship. I go here and then let me travel and then I have to go to Japan, something like that. I was thinking, maybe after that I find another scholarship somewhere, like doing something like that. But after that happened, it maybe changed my perspective a little bit. Like, I think I live in a borrowed time. Like, I maybe if I like to do research. I like even if I don't get paid. For example, I do random researching people, something like that. I just like to asking why and something like that. Or maybe I was one of my dreams, maybe being an FBI agent or something. Like, it's just I'm too weak for that. So after that diagnosis, I think like maybe I should change my focus in life. Like if I want to do research, maybe I should jump. At that time, I have no background about cancer, but maybe I can find a way somehow to learn about the disease. To, while I'm keep working and continue my life, but I want to do something that related to cancer. Because I was like underdiagnosed, and I before that I just want to have fun a lot. I don't really care. I was really young at the time. So, but after that, I kind of shifted. Like I kind of changed. Like I went straight vegetarian for 2 years after the diagnosis, and then hiking, because we live near the mountain. It was very beautiful. That's why I say I live in Taiwan. Like my apartment is like behind that. It's like a little hill or mountain. So. With the hiking path, it's very nice. It's not like here you can. Sorry, like the hiking path is like very walkable and very, very nice. So every day I went hiking, and then I went to beside the Western medicine that I have to biopsy control, something like that. I went to also Chinese Eastern medicine with the acupuncture, and then they really strict like what you eat, when you eat, how you eat.
Oh, really?
Yes, like. No ice cold, no something like that. Like going like that. Oh my goodness! Also praying, and then for 2 years, and then after 6 months, the biomarkers still there, and then the end of after the second years after that, I think it's clear my biomarker disappear, and then the biopsy was like. At first it was like inconclusive, like it's abnormal, but then after that it was clear, like nothing was there. So I feel like I have a second chance. Like, and then my best friend, they started getting bored, like we were like similar, and then they start getting scholarship from Australia, from Europe, from Singapore, like so they start going for PhD. And then at that time, like maybe this is my time, you know, like I looking whichever that have a scholarship. That I don't have to pay because I didn't have money to pay. The US is very and then somebody from Purdue University, and then they have that at that time was related to my research in work. So it's always changing. Like my research in master, it has to do with aluminum oxide, but not really like nanoparticle. But then when I work, the aluminum oxide changed into nanoparticle of aluminum oxide. But then in Purdue, there was a professor that study about using the nanoparticle for cancer, for killing cancer. So for the radiation therapy or so contrast agent, they also can kill cancer cell in breast cancer at that time. So I was like, oh, this is perfect. Like I have no idea. It was in a bioengineering, so it's still engineering background. So they accept somebody from engineer, and I was just going to be honest with him, like, hey, I have no background of cancer, but I have background of aluminum and making a nanoparticle. So if you take a shot of me, I can learn about it.
And you had a personal experience.
Yes.
Have some extra
motivation, maybe.
But at that time, I don't think he was the type that cared about the personal experience. And he was like, can you do this? Well, okay, I can make the nanoparticle from my work, right? So, but I just don't know anything about cancer, so I have to take classes or something like that. So be it, I will start over. My background is truly not bio, but he took a shot on me. I was very thankful. So I came and start over and studying and like that. But it's more like still very engineer. So we engineer a nanoparticle, and then he is more into optic. So what I mostly do was like using a lot of imaging and a high dimensional data processing. So at that time, try to differentiate a breast cancer based on the fluorescence imaging. Which stage of breast cancer? Apparently, when we try using this, my boss, my supervisor at that time, he had this spatial imaging system, like using a electron and then it will inside and then it will light something like that, like bioluminescence, but we call it like fluorescence. So apparently breast cancer in different states will have a different illumination.
Right.
Yeah. So my thesis was to generate a model and to classify this, like mathematical model to classify this, and then if we throw out an image of breast cancer, can the model guess is this which state? So it's something like that.
Yeah.
So, and then also making a biosensor from a protein that it's like a phosphorylation is like one of the process in the body, and then we try to make how to detect this phosphorylation, and each different cancer will have a different level of phosphorylation, and then we can image that event, something like that.
Right.
And that led me to my job in IU.
Okay. Before we hit IU, I've got at least 3 questions.
Yeah.
The first of which is, when you were doing your master's, you said trying to create fuel out of water.
Yes. Water gas.
I know nothing about that. However, the average human being would probably be like, oh my God,
no.
Is that possible? And like, how far away is that? Because if you can imagine, like, first of all, with global warming and the, I guess, percentage of water on this earth potentially increasing, and being able to somehow, if that's even possible, to utilize water for fuel instead of using petroleum-based products, that could be huge. Yeah,
well,
I mean, I'm stating the obvious.
Maybe I shouldn't say it because this is their like secret project.
Well, I mean, don't disclose anything that a confidentiality agreement has been signed for. But like, is it? Do you think it will ever get to the point where it could be mass produced?
I don't know about mass produce, but maybe China now probably take over with the speed of their R&D. It's all because of the budget. Everything is because of the more budget you have and the speed of the at the time.
I'm a little familiar with them trying to use hydrogen powered, and the byproduct of that is water, which obviously is not going to pollute the earth.
Yes.
Is there some relationship there, maybe a little bit?
Yes, the water gas shift reaction.
Right.
Yes, and I'm just playing a little part of it, like that optimizing that catalytic reaction, but not like the big people that has this.
Yeah, but I mean, can you imagine just basically pouring water in your car or pouring water in an airplane to fuel it? That would be awesome.
So I'd only need half this water bottle. I'll just tap off my tank real quick. It's really fine.
With the drinking.
Yeah, maybe in our lifetime, we'll get to see that. Who knows?
Maybe.
Who knows?
Maybe.
All right, so my second question is, we typically ask, what's your cancer story, and you kind of went into that.
Yeah.
If I can ask, when they discovered that biomarker, what was the treatment? You said you did both a little bit of Western medicine, but also a little bit of Eastern medicine. Like, kind of what was the treatment process?
At that time, I didn't really quite understand because my Chinese was limited with the Western medicine. They just give me medication and then follow up, like keep checking the biopsy. And then but the Eastern medicine, for some reason, they are very thorough. It's more elaborate tests. So they test the blood, everything, and then they check my heartbeat, everything like that. And then they do acupuncture, and then they make a journal. I have to make a journal of what I eat or something like that. And then they give me like suggestion, you should eat this, what you cannot eat, what vegetable you can eat, what you cannot. So I follow that strict regimen. And then the sleeping too, like what time I wake up, what time I sleep. Like they believe that circadian rhythm and everything, it all will contribute to the inflammation of your body, and that will fit your whatever you have, like that. So actually I have two, like first is the biomarker of the laryngeal this one, the laryngeal cancer or tumor, something like that. And the second one was the multiple polycystic ovary. It's not cancer yet, but they're concerned at that time. So after I follow this, so they also gave me medicine, Western and Eastern. I keep both because the Eastern have give me the regimen, like don't take it together with the Western medicine, something like that, so it will not be interfere. Like they're very they're very elaborate, more elaborate. The Western is more just, okay, this is your symptom, okay, we prescribe you something, and then you take, and then you follow up another 3 months, get ultrasound and get the biopsy, something like that. But so I just followed the strict regimen for 2 years, and then in the end of 2 years, I was clean. No polycystic, no clean everything. My skin was clean, my biopsy was clean, my biomarker disappeared, even better than normal people.
Wow, that's awesome.
So I was like, okay,
let's
ready
go.
to go.
Off to Purdue.
Yeah, exactly.
Off to Purdue,
All right, so then my third question is on the project that you're working on at Purdue, and I remember, I don't know, it was Dr. Lau that talked about this.
Oh, Philip Lau.
Yeah, or somebody else. I can't remember who it was we were talking to, but they were talking about how I'm not going to say this right, but the illumination of the tumor.
Yes.
And I think to your
fluorescence,
point, it would show different colors, but the different colors meant something.
Yes,
I guess my question is, and maybe AI will help play a factor in this too, but how do I want to say this? Oh, it's going to sound probably dumb, but I'm very good at sounding dumb. Could different colors basically signify what type of a tumor it might be?
Yes.
Is that what they're trying to get to?
Yes, that was one of my part of my thesis.
Okay.
The different color. Yeah, you can see a different color. So different stages of breast cancer at that time. It will show. This is because it, like for example, like breast cancer, it was hard to just at that time, like a couple of years ago, it was hard to right away distinguish, you are in stage 2, stage 3, something like that, and then how to guess, are you progressing or this is not progressing, or you're doing okay, and then this inside these different stages of cancer, they have a different metabolism rate, and this metabolism get a byproduct, something like that, and that when you hit with that light can emit a different color.
Right. Yes. I remember one story. It wasn't. I want to say it was prostate, but maybe it was not.
Yeah, prostate too, or any kind of.
Yeah, but I feel like there was a story that was highlighted, maybe in almost like a marketing piece, that there was a gentleman that was having all kinds of problems. They couldn't really figure out what it was, but and I want to say it was prostate cancer, but maybe it was something else. But they used one of those biomarkers and illuminated some color, and all of a sudden it which told them what they wanted to find out, and basically saved his life.
Yeah,
and I think it'd be really cool, especially because we all know the earlier you can detect something, hopefully
early intervention.
Right, it's going to be easier, in theory, to treat, and these types of tests might help us detect things much sooner than we might otherwise. And particularly for the cancers that are hard to uncover and don't present symptoms until they've already got to an advanced stage. How far are we away from some of that?
Because I do not do anything like that remotely, anything like that anymore. But I'm sure right now, especially with AI. At my time, there was no AI, so I went to 100. It's like 100,000, 150,000 point data one by one, and trying to make a model for it. But right now, AI will speed up the thing, and I think I think the most important is how can we translate that into something that is easy to use for the technician or for the patient? Like maybe one day it can be like a pregnancy test. Like you can just buy it, and then you just have to strip do the test. Yes, because right now, like for example, that microscope that I use, it was very specialized microscope. You have, it's not just for a general public, I'm sure they have the ability or intelligence to do it, but maybe not the skill or training. That it's hard to translate to use or navigate this specific or special tool. So I think now is the technology may be mature enough to differentiate, but it's not maybe not mature enough to translate it into something that is more user friendly.
Right,
Yes. So I think, but it should be, especially with the genesis of AI, and
Right. It's processing that data much more rapidly.
Yes,
Yeah.
and then it's more user friendly too, and then
Right.
maybe probably for the technician or the patient himself can maybe right now, maybe for the technician, if they go to the hospital and they have the microscope, they have certain the equipment, and then you can
Yeah.
you can like detect and diagnose. And I think they already use it in surgery. So
Okay.
not only this can differentiate the different stages of cancer, but it can also cancer cell and normal cell will have a different emission, right? Like it will light differently. So when you do like brain surgery, for example, it's hard to is this your brain? Is it cancer? When you cut it out, like
Right.
how much you should cut.
Yeah.
So they already use this kind of similar, not exactly the same.
Cleaner
similar-
margins when
yes,
they're doing
cleaner
a
margin.
removal.
Yeah, so
Yeah.
they have like light up. Oh, this is cancer. Take it out, and then this is not. It's like
Right.
already guide and aid the surgeon to do that.
Okay, cool. So you finished your PhD at Purdue.
Yes.
What led you then down here to Indianapolis?
Okay, so my planning, so always something like that. Like, so my planning was when I first came here, my planning was I want to finish my PhD. Either I came back to Taiwan, like my boss was like, just come back when you get a PhD. We are here, or I want to go to Europe for my postdoc, like change another countries. I usually move every 6 years, move to different country. Like, but then at Purdue, I met my husband.
Okay.
So then I decided not to go anywhere. and then my husband at that time, before we got married, before he went into medical school, and then after that he went to medical school. He got it like in West Lafayette. So during I finished my PhD, he finished his medical school, but then he got his residency in IU. So I have to follow him to Indianapolis.
Okay.
Yeah.
Got it.
So I have to find a job at that time and find someone. And because I work in the fluorescence and biosensor about phosphorylation to differentiate the different cancer. So one of the PI at that time, he worked in a project that will benefit from my sensor because it was kidney cancer, but it's resistant. So apparently with my biosensor, it's a similar line with that. It will light differently if you have a resistant. So I helped him during I met him in the conference, and then I shared about my biosensor. I wasn't looking for a job at that time. I just sharing about my biosensor, and then he was interested, and to complete his paper, he can use that. And I helped him during my time in Purdue. So when he heard that I was moving to Indianapolis, and then was like, why don't you just join my lab? That was the starting point. And then I was more into patient center at that time, because in Purdue is more into engineering. I still making a model like computational or something like that. But then I moved to IU, and it was my first experience with patient sample, something like that. Okay, and then after that he has to move because he received a bigger position.
Okay.
So I cannot move because my husband has not finished his residency. So, and then I joined my husband department because they said rather than my husband move to follow me, why don't you join us to follow him?
Yeah.
So I move again. Okay. So, but that when I was joining with Dr. Pollock, I was tasked by this new pediatric cancer, especially pediatric high-grade glioma. That was I first learned about pediatric brain cancer because it was the first number one solid tumor most prevalence in children.
Okay.
And then my job was actually more into rare pediatric cancer, and this is the one that Heroes Foundation, like generous support from Heroes Foundation meant a lot that we can carry on of this project.
Yeah. So if you would describe what that project is,
Yes.
I mean to the general layperson,
Yes.
what the project is, and then like you guys have been working on this for a couple of years now, is that right?
Oh yeah, 3 years.
3 years.
3 years.
And, like
yes.
what have you seen since the early stages of the project to like
Yes.
kind of what you guys are seeing now.
Yes. I work in a rare pediatric brain cancer. It's called anaplastic pleomorphic centroastrocytoma. So it's a
Did you get that?
I would not be able to repeat that back.
it took me
I was
some
starting to write
time.
it down.
Yeah.
No, don't worry. It took me some time to be able to remember to we
What-
call it
what's-
EpiXA.
Okay.
EpiXA. Yeah, we call it EpiXA.
I was gonna say, what's
Okay.
that?
Yeah.
Sure, there's an acronym
Yeah.
for that.
So when I first joined, like they just have this. When I first joined, what happened was there was a young boy that diagnosed with this EpiXA, and up to today, there's not much known about this disease of EpiXA. Why? Because it's rare. When you get into rare disease, especially with child, there is not enough interest. There is not enough funding.
Right.
Nobody want to fund government fund rare disease, but this is super rare. It's
Yeah.
a very infancy, and then
Yeah.
not many known. It's like high risk project. It's harder to find funding. So at that time, this boy was diagnosed. His name was Christian, and then his parent, unfortunately, he passed away because there is no standard treatment. There's not much known about this. So what Dr. Pollock at that time, my mentor, did in his lab, Dr. Pollock did a lot with pediatric sarcoma. So it's a rare. So what they do is they always make the model. So they take a little bit tumor from the patient and they implant it to the mice, and then they try different drugs in the mice so to
Right.
test whether the drug working or not. So Christian parents came to Dr. Pollock lab. They want to donate the Christian tumor, and they have some startup funding for the research, but nobody did that project. And at that time, my husband department, the Department of Neurosurgery, after they hire me, they have a close collaboration with Dr. Pollock, and then Dr. Pollock, okay, because it's perfect timing because the sample come, the funding has funding for that, and then we should start building this to start to make a model for Christian to learn about the tumor. And now I truly believe that making a model, especially for rare cancer, is very important because tumor in a brain especially is very small. So
Yeah.
it's hard to do anything with small, right? So with
Yeah.
the model, you can amplify the number of samples that you can study the genetic, or you can
Right.
study the response to the drug, something like that. So that's
Yeah.
what's my first encounter, is to develop the model from the sample of from Christian, and then we developed the model, and then we did the sequencing. Our first publication was to characterize, in order to the model. The most important when we make a model is how much the fidelity of this model to the original tumor. So the way we assess the way that we measure this fidelity is by characterization with sequencing. So we compare the molecular profile, the model, and the tumor.
Okay.
That was my first job.
So you jumped in head first into a
Yeah.
very difficult
Yeah, another-
form of
Yeah.
cancer, hence the term rare, of course. If you would, in as basic a way as possible, why is brain cancer? I don't know that there's multiple types of brain cancers, but why is brain cancer such a difficult form of cancer to treat?
Yeah, that's a great question. It's a hard question to,
I mean, some people may have heard about the blood-brain barrier, but what is that really, and what makes that so
yes.
difficult? I kind of know, but for our listeners and viewers,
the thing is, yes, because it's hard to, first of all, usually the standard treatment of brain cancer is surgery.
Mm-hmm.
You just have to do surgery, and then the research itself for brain maybe is not as mature as lung cancer or breast cancer. And again, it comes back to the number, because top 5 in the world is breast, prostate, lung, and U.S. as well, brain disease, even though it's the most devastating.
Right.
So the investment in it's not as big. So
Right.
the research is not going as fast. And
Yeah.
then blood-brain barrier, scientific speaking, blood-brain barrier, yes, is very important. So you have it's like a barrier that you can just deliver the drug to the cancer. You have to pass through this like inhibition that in a way is a nature way to protect the brain,
Right.
but it's also a barrier to anything that try to pass through.
Yeah.
But right now the technology is mature, like not mature, like advanced maybe, that we can do like ultrasound guided therapy or something that make a way, the surgeon can make a way to go through the blood-brain barrier to deliver the drug, something like that.
Interesting.
But still come back to the research,
Yeah.
you know, it's not as big as breast cancer. Because why? Because breast cancer is the number one cancer that affects. So for
Yeah.
pharmaceutical industry, for example, if you want to invest in a drug, you need the market.
Right. Yeah.
So
Yeah.
brain cancer doesn't give you
So
market.
this is. I'm glad you went there. This is a tough conversation. For some, because pediatric cancer, as you noted earlier, is severely underfunded.
Yeah.
And so from I'm not gonna say this right, so don't at me on this, but like from the humanitarian side, you think about it, you're like, oh my God, it's awful. Like, why are we not investing and putting forth more resources?
Yeah.
The business side says, well, the reason why there aren't as many
There's no
resources
market.
because the market is so much
Yes.
smaller. Anybody who's been affected by that would be
Yes.
adamantly opposed and would want to fight that battle every day of the
Yes.
week. And
Yes.
I'm happy to join them. I agree 100%.
Yes.
Which is why one of the reasons why we wanted to fund this project was because A, it's underfunded. B, I think there's a lot to be potentially gained for everyone,
Yes.
not just the peds patients being
Yes.
diagnosed, but all on up to the adult side.
Yes.
Just as some of the adult projects hopefully then can also maybe help
Yes.
peds
Yep.
side.
Yep.
To me, what's also very intriguing is brain cancer in general. Like just in the last 10 years, we had the story of Joey Keller, which is what was the impetus for the Team Joey program.
Oh yeah.
But then also I've had some adult friends of mine have GBMs and not a good
sorry.
diagnosis.
Yes,
It does not
yes,
have a good outcome.
yes.
We've lost a couple of friends who
GBM. Yes.
didn't even see their 50th birthday yet.
Yes.
Yeah.
Yes.
And that it goes back to what you said. So surgery,
Yes.
which has
There's
a lot of
first.
issues. As that
Yes.
tumor grows, it puts pressure on the brain, which can cause
Yes.
other issues.
Yeah.
Then the surgeon has to go in.
Yes.
Very difficult surgery. Sometimes almost impossible to remove the whole tumor.
Yes.
And then even if you can, in some instances, you're also damaging. You can
Yes.
damage the
Other
brain in
functional,
no other way, and so
yes,
that
yes.
causes.
Quality of life. You
Right.
will lose your quality of
Correct.
life. Yes.
And then beyond surgery, if you're trying to treat that tumor with some
Chemotherapy.
variation of chemotherapy, then
Yeah.
as we talked about
It's
that blood-brain
another-
barrier, how do you
Yes.
get those drugs
Yes.
to the area that you
Yes.
want?
Yes.
Because
Yes.
for better and worse, you have a defense mechanism, which is great for keeping things out, but when you're trying to get things in, it
Yes.
causes a problem. So super challenging.
Yes. But I think come back to that, like why breast cancer and prostate cancer, like some of them can be indolent disease, like you can live with it, like diabetes, because they're heavy. You hit it with research, like
Yeah.
so big funding.
I think it's twofold.
Yeah.
Number one, just percentages, right?
Yes,
The number
yeah.
of people being diagnosed is much greater.
Agree,
At the same
yes.
time, the number of people surviving those is also much greater. So you have, thousands of survivors who have been
Yes.
affected by this experience who
Yes.
say, all right,
gonna-
I want to band together.
Yeah.
What can we do? And so you have
Yes.
a much
Yes.
bigger army per se
Yes.
of advocates wanting
Yes.
to raise funding
Yes.
and go after that form of cancer. GBM survivors are nearly
Yes.
non-existent,
Yes.
and so you would have to rely on those caregivers and family members who
Yes.
have been affected by losing a
Yes.
loved one to then
Yes.
want to do something.
Yes.
And for whatever reason, that number is just not as great, and so
Yes.
they're just not as big of an army. But I think that's why it's reliant on organizations like the
Donor,
Heroes Foundation
yes.
to look at
Yes.
these projects that are attacking those rare forms.
Yes. This small niche.
Right. Because
of
again, and I'm not a
yes.
researcher, so correct me if I'm wrong, but like I would think that while you guys are really trying to research and go after this particular form of, this APXA, you may also glean things from that research that help out other areas.
Actually, EpiXA is a glioma, so it's belong to glioma, and glioblastoma is also a glioma. So glioblastoma is the end. So if it is a country, probably they are like Japan and Indonesia and Taiwan in the middle, and the EpiXA is like Taiwan
in the middle.
So it's in the middle. So we call it WHO3, like the level of the given by the World Health Organization. Like they give a grade in brain tumor. It's a grade 1, grade 2, grade 3, and grade 4.
Okay.
So glioblastoma is a glioma that has grade 4. So it's like the most devastating and lowest survival. And then EpiXA is grade 3. But it's actually started from PXA, which is grade 2. So it's like a very unique entity that it started from grade 2, which is non-malignant and can be very indolent. But it can progress to the grade 3 EpiXA and can even progress to glioblastoma. So it's like the turning point, like kind of that can be a turning point. And speaking of the donor, one of our project, aside from the project from Hero Foundation, it was actually funded by the husband of Joan Carey. Like she was a glioblastoma patient, and then in memory of John Carey, Brian Carey, he donated every year. He will come and then listen to our research story, and then he supported us in certain project, which I aside from Heroes Foundation, we try to do the sequencing of the archive of the EpiXA and GBM and PXA patient in IU, and we sequence them, and we try to classify them based on the molecular signature, because right now we don't know what is the molecular signature of this. So we want to mine, we want to extract this, we want to know what is the biomarker of the PXA and glioblastoma, what drive the progression. That's what we really want to know. So we want to learn. We just finished the sequencing. I have to analyze it. I haven't started the analysis.
So when we spoke 6 months ago, we all went to lunch. If you would, what's been the most significant findings so far with this project in the last 3 years or so?
Which one? The one with Heroes Foundation? Because it's very different.
Yes.
Oh, the most significant is that even within the same EpiXA, the same disease diagnosed EpiXA, even within that, if you have a different status of BRAF, so it's one of the protein. So in EpiXA patient, their BRAF mutation are different. Some of them has a V600E mutation, some of them has a fusion mutation, some of them has a wild type, which is no mutation. Even the same type of rare tumor, EpiXA, if you have these 3 different BRAF status, you will respond differently to the same drugs. Some of the same drug, the drug is anti-BRAF. It's like new from a pharmaceutical, like from we call it, maybe can be a breakthrough. You if you have EpiXA, you can treat it with targeted therapy using anti-BRAF. But apparently, if you have a different status of BRAF, a mutation of BRAF, you will respond differently, and then not only respond differently, you will respond differently with a different dose and a different combination ratio. So some of it even make it worse. So if you give the same drug, a different dose, in a different BRAF mutation, you will make the patient get worse. But with the right dose and the right mutation, the tumor can regress. So this is 6 months is what we learn. And we also learn this new type, newly approved, FDA approved type 2 inhibitor of BRAF from a new company that we have. They also provide us funding to test it in our model. Have a wonderful result that the tumor disappear.
Oh, wow.
With this new type 2 BRAF inhibitor. So at that time we met, what we try is type 1 BRAF inhibitor. They already FDA approved. So this is the thing that the project with Heroes is like, the idea is like this, because this is rare. There is no drug. So what we do is, what kind of other cancer they also have similar mutation, and in this case, in my model is BRAF mutation, the cancer is melanoma, and melanoma is number 5 most cancer in United States.
Yeah.
So the R&D is advanced and they have a lot of drugs, and that what we want to try is the BRAF inhibitor. Like learning from melanoma, can it be used in this APXA because we have similar BRAF mutation.
Yeah.
And then it worked, the type 1, but only in this V600E mutation. In the other model, at that time, the fusion and the wild type, depending on the dose, it's like the response is very different. And even in wild type, higher dose even make the tumor even grow. So 6 months later, when we met with industry, they have a new type of the inhibitor, and we tested in the fusion that otherwise did not respond to the type 1. It respond very well and the tumor disappear.
Wow.
But it was a flank model, so we tried to make a model in the brain, and that was our struggle this couple past month. Like it couldn't grow in the brain, our model, but recently just grow like last month. Like it was when we take, and then I took them to imaging to try to see is it really growing from the brain. And I haven't. Maybe next week I will have the result to confirm that our brain model working, and we will test the same drug in the brain model to see if we have a response. So that's where we are. Like,
cool.
That's pretty awesome.
That's in a mouse model, right?
Yeah.
We will hopefully we can translate that to the patient, go to clinical trials.
Sure.
Yes.
I guess one last thing I want to ask you about is how do you put or how do you guys value external funding like what the Heroes Foundation did? I mean, as a researcher, how important is that?
Oh my God! Like for me, it's like everything. I cannot do anything without because yes, I had my salary from the department, but there was no funding for the research. We cannot move forward. So each project has different source. And then I got some funding from my proposal, for example, certain projects, small funding. So at that time, I got seed funding from SCS, American Cancer Society. So my proposal was funded in a line of the Heroes Foundation. But if Heroes Foundation didn't give me that funding, then I have to stop at that point, just like the type 1, and then we didn't have money to do the sequencing. We just measure the tumor, but because Heroes Foundation gave me more funding, then we send the sample to the sequencing, and then now we are ready to analyze to see why different BRAF status in the same type of tumor give a different response. So we will learn about the molecular behind the drug response that will hopefully inform the physician and the patient later, like how important is this personalized. Like there is no one size fit all in treating cancer, especially pediatric cancer molecularly heterogeneous. You have the same type of tumor, APXA. Like you can be diagnosed, oh yeah, you have APXA, and can I give you this drug? Oh, wait a minute, you have to depend on your genetic makeup.
Yeah.
So hopefully we can set a little light in that, like how important it is to take a lot of factor into designing your treatment. So Heroes Foundation, we thought that I wouldn't know, and then we thought Brian Carey, the archive, like. I collected all the archive because it's rare. So right now that we collected is 58 sample in spanning on 20 years.
Okay.
It should be, until this point, it will be the biggest archive in the US of the APXA and PXA.
Okay.
And some of them is glioblastoma, but we cannot include all the glioblastoma because it has to be like at some point diagnosed with PXA. So has to be belong to, so that one. But hopefully we can learn too, like what make it from HU2 to HU3 and then progress, what molecular signature behind it, and is there any molecular target that we can identify as actionable target. And then we can find in another disease like BRAF, for example, and we can find another more high population disease, a cancer that has similar mutation, and we can use their drugs that already established or FDA approved, and we have a good response, just like when we tried with BRAF, something like that. But there must be a lot of other molecular target, not just PREF.
Sure.
Yeah.
So really, at the end of the day, none of this progress can be made without the
Heroes
external,
Foundation. Yes.
external funding,
yes.
whether it's American Cancer Society to all the smaller organizations like the Heroes Foundation.
Or patient, like Brian
Or
Carey.
patients.
He just give his own personal funding.
Yeah, I mean, absolutely.
Yes.
From individuals to small nonprofits to the larger
Yes.
national
yes.
agencies,
Yes.
none of this happens without funding.
No.
And so,
Yes.
folks, we just want, the reason why I say that is I just want you guys to know, whether you're already contributing to the Heroes Foundation, thank you very much. If
Thank
you
you.
haven't, whether it's Heroes or any other organization, these advancements in research don't happen without dollars. It's that simple.
Yeah.
And, on occasion, I've been accused of, you're only focusing on raising money. Like, yeah.
Yeah.
So,
Yep.
I'm not gonna go down that road.
Unfortunately, that's what buy the reagent. Unfortunately, yes, we have. Unfortunately, I think like a physician, physician is a calling, and then a researcher like me is a passion. Like we have to have a passion.
Right.
But all of us is working under healthcare, and healthcare is a business.
Yeah.
It is, but I'll tell you this: it's not just your training and the academic side that has gotten you to where you are. It's that passion factor. Like I'm not academic. He'll tell you.
Yeah.
I would never be able to get a master's, let alone a PhD. But that passion piece, not everyone has. And that passion piece is hugely important, right? Because people get burned out on their jobs, whatever it is. Whether it's, business side to the research side, whatever. But if that extra passion helps get you pushing through that boredom or pushing through that burnout and helps you, achieve just that much more. I truly believe that. We talk about grit all the time. I think it's that passion that fuels that grit. And so we really appreciate researchers like yourself who have that, who aren't just doing that just because it's their job. They're doing it because they truly have a passion for wanting to see positive results and making a difference for everyone. And I think here's what's cool about this episode too. I was born here in Indiana, as was Daniel. You were born in Indonesia. Like, cancer doesn't care, right?
Yes.
Doesn't care if we're American, you're an Indonesian. It doesn't care.
Yes.
Every nationality that I'm aware of is affected by cancer. And so this is a global issue, not just a Indiana or U.S. issue. The Heroes Foundation may be focused on, battling cancer here in Indiana, but maybe what's discovered here through the likes of IU, even Purdue, Notre Dame, et cetera, and everyone in the state. We have some great institutions here, great researchers here. Who knows, we can impact the rest of the world.
Yes, yes. 20 million, around 20 million impacted by cancer per year in the world. And then 10% of it come from the United States, around 2 million.
Those are big numbers.
Yeah.
Huge.
All right. Well, Doc, we appreciate you coming in and sharing your story. We appreciate what you're doing and in the lab there at IU, and we're happy to fund you guys and happy to
Thank you.
Be partners in this battle.
Thank you very much.
Yeah, you're welcome.
Yeah.
We look forward to the trip.
Yeah, exactly. Yeah.
All right. Thank all you guys for joining us on this episode of the Summits Podcast. We greatly appreciate you guys tuning in. Hopefully you all learned something new today, both in terms of what they're working on, but also how important your funding of the Heroes Foundation is, so we can turn around and put that money to work in the lab. Until next time, don't forget, guys, beat cancer.